We'll start our course with some very basics, and we'll start by looking at data visualization. So to begin, in statistics, the data we work with either represents a population of interest or else a sample from that population. Population just means a large group which we'd ideally like to know about. Sample means a small group that we can actually look at. And population does not have to mean people. That's important. In either case, we describe the individuals of the population by variables of interest, which are either categorical or quantitative. A variable is just some way of describing an individual that could be either that changes from individual to individual, and it could either be a category or it could be a number. So if it's a number, it's quantitative. So we might be interested in all Edgewood College students. So the variables that we might be interested in could be academic major, that's a category. GPA, that's a number, that's quantitative. Gender, that's a category. Hours per week employed, that's a number, quantitative. Credits in progress, that's quantitative. And it might be difficult to get data for all 2,500 students, so perhaps we look at a sample. First, we'll be talking about descriptive statistics, where the goal is simply to describe a population or a sample in order to understand it, in order to see patterns, to be able to summarize it. And to do this, we use data visualization, which is what this screencast is about, and then numerical summaries. So with visualization, we look at graphs, charts, or other visual summaries. And here, we're just going to look at the few of the simplest kinds of visual summaries, just the very simplest. We'll take, for lots of our data, we'll take some houses that were for sale in Dane County or in Madison, which you can find in the data bank section of our Blackboard site. And we'll use this one data set to introduce all of our major kinds of graphics, although we'll use some other data too, some made-up data. So first, categorical variables. If you have one categorical variable, the two kinds of visuals are pie charts and column graphs. So let's look at those. So a pie chart lets you see proportions of a whole. So in Madison, of the homes that were for sale, boom, 83% did not have a finished basement and 17% did have a finished basement. So if you're a realtor or looking for a house, this chart tells you a lot. Mostly, you're not going to find homes with finished basements. This one, we've technically taken quantitative data, which is the number of bedrooms a house has, and turned it into a categorical variable. So we're treating the number of bedrooms not really as a number, but as a category. It's a one-bedroom house, two-bedroom, three-bedroom, 4, 5, and notice 6 or more. And here again we can see that 59% of the houses in Madison had 3 bedrooms. It's relatively unusual for it to have 5 or more. And embedded in my PowerPoints are directions or reminders of how to create these things in Excel, but we'll have a separate PowerPoint walking you through it. This is just a one-page reminder that you'll see embedded in some of my PowerPoints. Now with column graphs, that's when you want to know the actual numbers and not just the proportions of a whole, when you're not trying to divide up one pie. So if you're looking for houses for sale in the Madison area, it might be important to know how many houses were for sale in each of these communities, not so much the proportion of all the houses for sale in the communities. So here we see, oh, okay, at that time there were over 200 houses for sale in Sun Prairie, only, I don't know, 55 or 60 in McFarland. So again, a very simple type of visual that shows 5 different communities and how many houses were for sale in each. Again, a reminder how to do it. Now, a histogram, this is more complicated. Histogram is a visualization of one quantitative variable. Here we have data on 120 employees at Pearl's Pretzel Factory. And how do we read this critter? Well, down here you see 40K, that's $40,000. Up here is $50,000. So this column here is the range from $40,000 to $45,000, and it goes up to a height of 7. That's the number of employees. So about 7 employees made between $40,000 and $45,000. How many people earn between $50,000 and $60,000? Let's estimate that. Well, this column, that's going to be $50,000 to $55,000. This column, that's going to be $55,000 to $60,000, so we need to add those two. So maybe this goes up to 22, looks like this is 25. So approximately 47 employees make between $50,000 and $60,000. That's how we read these column graphs. Down here on the horizontal axis, we see the range that our data was in, and on the vertical axis, we see how many of the units or how many of the individuals were in that range. So the raw data we used to create this graph was the salaries for 120 employees at Pearl's Pretzels. What salary puts an employee in the top 10%? Well, top 10%. 10% of 120 is 12. So how well do you have to be paid to be in the top 12? Well, let's see. It looks like we have maybe 2 employees up here at more than 80,000, maybe 4 between 75,000 and 80,000. So these two are 6. On the other hand, this one is 10. That would be 16 employees, and 10% of 120 is 12. So we're looking somewhere between 70 and 75,000. So we might estimate that top 10% as being 73,000. That wouldn't be a bad estimate. 74, 72, they'd be okay too. 70, that's too low. 75, that's too high. If you just look at where the 12 employees are going to be. Here's a histogram of the prices of houses in Madison. And notice it's pretty complicated picture, pretty different shape. So this is 200,000 to 300,000, and then this one will be 300 to 400, this will be 4 to 5, and this will be 5 to 6, and that's why it lands on 6 here. So you see that most of the houses are in the 100,000 to 200,000 range, or 200,000 to 300. I've got about 500 of these homes cost between $100,000 and $200,000, and another 380 or so were between 200 and 300,000. So again, histograms are great for seeing one quantitative variable. And it can be done in Excel 2016, but they're not pretty, and we'll see how to use a website called Plotly to make histograms. Now, a box plot is another way of displaying one quantitative variable, and again, it'll be done using Plotly. This is a box plot showing the height of 1,000 U.S. adults, and it's got this rectangle here with a line through the center. It's got a bar up here and a bar down here and a couple dots here. So let's see how to read a box plot. So this center line, where does it come in? It comes in around 66. So and that's 66 inches. What this line is telling us is that 50% of the 1,000 people are at height of around 66 inches or below, and 50% are above. So it's the 50% mark. How about this here? Well, that's the 75% mark at the top of that box. That's about 70 inches. So about 25% of the people are more than 70 inches, and 75% are below. And down here, that's the 25%, or the 25 percentile. That's about, I don't know, 63, 60, somewhere in there, 63 inches. These dots represent outliers, just extreme values, and these are called the whiskers. We'll talk about this in class of how you draw these when you have outliers. If you didn't have any outliers in this box, this line down here would be the very smallest height you had in your whole data set. But we have a couple outliers, and so it's a little complicated where to draw these. But basically, this lets you see the percentiles. So what proportion of the sample is more than 70 inches? Well, 25%. That's because it's at the top of this rectangle. 50% are how many inches or less? Well, again, that's this line, about 66 inches. I don't know, 65, somewhere in there. So that's how box plots work. And they can be especially useful. Oh, here's a box plot for the Madison home prices. Notice there are lots of outliers, which shouldn't be surprising because there's some really high prices, and these are thousands of dollars. So this is $600,000 and $1 million. Box plots are especially useful for comparing two or more quantitative data sets. So with this box plot, again, of prices of homes, we see, oh, so Fitchburg and Verona look pretty much the same in terms of how much the houses cost. and they clearly cost more than Madison homes, although Madison has some extreme outliers that are more than anything in Fitchburg or Verona. So this is a great tool when you've got one quantitative variable that you want to compare across 2 or more samples. And a final visual is a scatter plot. A scatter plot shows the relationship between 2 quantitative variables. So down here we have the size of a house in finished square feet in Madison, and up here we have a price. So this dot right here represents a house that's huge. It's about 6,000 square feet, and it's very expensive. It costs $2 million. Down here we have houses that are 1,000 square feet, and you can see there's lots of them here. We can't even see how many, but they all cost a few $100,000 at most at 1,000 square feet. And what this scatter plot does is it shows us the relationship between the price and the size, and it's not very surprising. It shows us that in general, bigger houses cost more. As you move from left to right, you're going up. And here's how to do that in Excel. Okay, so in this short screencast, we've seen 5 of the common graphs for displaying data visually. Pie charts and column graphs are for one categorical variable. Histograms and box plots are for one quantitative variable. And scatter plots for the relationship between 2 quantitative variables. Excuse me. In our next screencast, we'll see how to summarize quantitative data numerically.